Hello everyone. Let's take a look at some selected questions from the math review. So these are not all the questions, just a selected few. If after this video you still have some problems, please contact me for help. Okay, let's take a look at this. We are working with exponents, and in the math review I put in some of the exponential rules that we'll be using. So right here, the second line that I would write is this, right? 2 to the power 1 over 5, x to the power 1 over 5, because we can just distribute that power over the items within the parenthesis. Now I can go ahead and divide through by 10, right, and get rid of this 10 here. I'm trying to get x on its own, and so I have 4 equal 2 to the 1/5 x to the 2 over 5 x to the 1 over 5, and I'm taking this step by step. So in case you already know where this is headed, good for you. All right, divide through by 2 to the 1/5. Are we done? No. Look at the x. Well, the two of them, they are multiplying each other, and so their powers would add up. And here we have x to the power 2 over 5, and in the power we add 1 over 5, and all of that is equal to 4 divided by 2 to the 1/5 power. Okay. And so from here, we will have on the left hand side 4 divided by 2 to the 1/5. If you notice, I haven't put that into my calculator yet. X to the power, well, 2 over 5 plus 1 over 5 in the power, right? That will give us to the power 3 over 5. And to get this x on its own, what do? I do this. To clear the power, so let's use a different color now. To clear the power on x, I will have to raise x to the power 3 over 5 to the power 5 over 3. That way the powers, right, the ratio will cancel out. So then I have my x on its own. And now I can put all of this into my calculator, and the answer should be 8. You could do this in 2 steps, right? So those of you who were able to do that, that's great. For those who needed to see the extra steps, well, here they are. By the way, these cancel out so that the x can stand on its own. All right. The next question . The next question is still using some ideas from exponents. So I noticed some students were taking 4 over 2 and then take the x's, x to the power minus 3 over 5 divided by x to the power 2 over 5. Sure, you could do that, but hopefully you know it's the 4 divided by the 2, and if I change to a different color, it will be the x over 3 to the power 3 over 5 divided by x to the power 2 over 5. And if I use the different color, it will be the y to the power 1 over 5 divided by y to the power minus 4 over 5. You could do that, or you could just do it in one swoop. And what do I mean by that? Well, all of this will equal, or the 2 goes into the 4 twice, and so all of this will equal 2, and with the x to the power 3 over 5. Well, when you have x to the power a divided by x to the power b, you can rewrite that as x to the power a minus b. So I'm going to do that. Minus 2 over 5. And then for the y, I have y to the power 1 over 5 minus negative 4 over 5. And so from here, I can write this answer as 2 to the power x. Well, minus 3 over 5 minus 2 over 5 is minus 1. And 1 over 5 minus 4 over 5 is 1 over 5 plus 4 over 5, and that's y to the 1. So we can rewrite this as 2y over x, and that will be the answer. Let's move on. Derivatives. We are using power rule. And what do I mean by power rule? Well, if you have f of x equal 5 times x to the power 3, the derivative of f of x with respect to x, which is the same as saying, well, changing f of x over changing x, you will have your 5, you bring down the power on the x, multiply it by your 5, and then in the power on the x you subtract 1. So at the end of the day, you're going to get 15x to the power 2. Let's clean that up a little bit. 15x squared. Good. Here's another one that you should be aware of. If your f of x is equal to a constant 20, then the derivative of f of x with respect to x, well, there's no x there. Really, well, there is, but it's x to the power 0. X to the power 0 is 1, right? So, well, 20 times 0 times x. Zero. Well, 0 minus 1, right? At the end of the day, we're still going to get 0 because it's 20 times 0. And so the derivative of a constant is 0 based on this power rule I just showed you here. So, okay, if we had, for this particular question, let's use red now. If we had the utility function of two goods, so our consumer is consuming two goods, good x and good y, and this is the utility function 10x to the power 2 over 5, y to the power 1 over 5. The marginal utility of good x, right, that's the derivative, well, in this case, the partial derivative, of the utility function with respect to good x, right, will be written as, well, 10 times the power on x, 2 over 5, times x to the power 2 over 5 minus 1. Now, we treat y here as a constant because we are not taking the derivative with respect to y. So y is treated as a constant. Now, 5 goes into 10 2 times, and so the answer is 4 times x to the power negative 3 over 5, y to the power 1 over 5. In that same spirit, if I were to find the marginal utility of good y, then mu y is equal to the partial derivative of the utility function with respect to y. Now you can pause the video here and see if you can get the correct answer on your own, just like I will be doing in a few seconds. Right? So 10 times the power on y, 1/5, times x and its power, times y, and in the power of y, we subtract 1. And so 5 goes into 10 2 times, so that's 2, x to the power 2/5, y to the power minus 4/5, and you're done. Well, for these two. We move on to calculate marginal cost. Now, if you've taken any of my econ classes, in the principles classes, we tell you that marginal cost is calculated as change in total cost divided by change in Q. What is total cost? Well, total cost is calculated as variable costs plus fixed costs. And so this is the same as writing change in total cost. Change in variable cost over change in Q plus change in fixed cost over change in Q. What did we tell you about fixed costs? Fixed costs remain constant regardless of whether you produce some Q or no Q at all. And you know that the derivative of the constant is 0. So this is going to go to 0. And so to find marginal cost, you can either take, if you had the total cost, you can take the derivative of that with respect to Q, or you take the derivative of the variable cost with respect to Q. So let me rewrite that. Marginal cost is calculated as change in total cost over change in Q, or change in variable cost over change in Q. And using the derivative symbols that I have been using, this will be equal to I almost missed that one. dq equals dvc dq. So if I have this total cost here, which part of it is variable cost? Well, the part that varies with quantity, right? So I'm looking up at my total cost function here towards the top of the video, right? So my total cost function is 20q squared plus 10. So the 20q squared part is variable cost, and the 10 is fixed cost. Okay, so now for the answer, right? And I'll write that in green in this corner here. Marginal cost, which is equal to the derivative of the total cost function with respect to Q, will be written as 20 times, you guessed it, the power on Q, 2, times Q, and in the power on Q we subtract 1, plus 0, because the derivative of a constant is some number, some constant value, like 10, 11, 100, 1000, a million, right? That's 0. Anyway, the answer here is 40q. That is our marginal cost, 40q. You can pause the video and take a good look at this. But I'll move on. Antiderivative or integrals. That's the indefinite version. We can back out the total cost. If we had just marginal cost, we can back out the total cost. So what did we do above? What did we do up here in B3? In B3, we had the total cost function, and we calculated, or we derived, marginal cost. Well, if I gave you marginal cost, can we back out the total cost function? Yes, we can. Yes, we can. And it's, well, just doing the reverse of everything we did when we were working on the derivative, which is what? Well, to back out the total cost, we will have to take the 40 and that q. In the power of q, there is 1, right? Q to the power 1 can just be written as q. Well, we add 1 in that power and divide the whole thing by that 1 plus 1. Are we done? No. We also have to acknowledge a constant here. Why? Well, think about this. This is total cost that we're trying to find. So when we do write the total cost, it will be 40 q squared over 2 plus the constant. Are we done? No. One more second and we'll be done. The 2 goes into the 40 20 times, and so we have 20 q squared plus the constant, whereby this is total cost, and so what we have here, the 20 q squared, is the variable cost, and so some constant is the fixed cost. Now, what is the constant? We don't know. We just have a constant to account for the fact that fixed cost is a constant value. Okay, and that is it for the selected questions that I wanted to focus on in the math review. If you have other questions, please let me know. Okay, goodbye.